Assalamualaikum and good day to everyone. This is the chapter 1 EXERGY and for the video for part 2. So in this video I'm going to explain the reversible work and irreversibility. Reversible work and irreversibility. Okay, reversible work and irreversibility. Okay, we already looked into the EXERGY analysis, and in the EXERGY analysis, we consider only 2 points, which is from the initial state to the final state, and we also consider the final state is the dead state. However, in the actual engineering system, such as this, which is the steam turbine system, it is hard to achieve the dead state since the system final state of the system is not at the dead state. So, and in addition to that, the analysis is not fixed for only 2 states. So, as you can see here, this is an actual gas turbine engine cycle. So, we have 4 cycles, and the system will return back to the point state ones before the system can be turned to state ones. So, in addition to that, it's not isentropic process. Isentropic process limited to adiabatic process. As you can see here in the TS diagram, so the process from 1 to 2s, and then 3 to 4s, and then it return back to 1. So 1 to 2s is the isentropic process, whereas 3 to 4s is the isentropic process. However, in the actual system, it does not appear like this one, whereas it will goes from 1 to 2a, because we have it's not really an isentropic process, and also from 3 to 4a, because we have some also the same case, which is it's not an isentropic process. So in order to know the actual exergy of this system, we need to know 2 quantities related to the actual initial and final states. So the 2 quantities are reversible work and also irreversibility. So useful and surrounding works. Surrounding works. So before we go to the definition of irreversibility and also reversible work, we should look into the surrounding works. So let's say we have a piston device system. On your left hand side is the state 1, and on your left hand side is state 2. Initially the system is at state 1, and then it changed to system 2. We have pressure applied to the cylinder that move up the cylinder. So this process is called the expansion. So here the useful work W is equal to boundary work minus work of the surrounding. Boundary works if the work done by the piston, which is the movement of the piston, and the surrounding work is the surrounding by the atmospheric pressure, work done by the atmospheric pressure. Why it is in negative sign? Because the boundary work is in the opposite direction with the atmospheric pressure. So we can expand this equation to be something like this equation as shown in this slide. And then the next stage is state 2 goes back to the state 1. So as you can see here, the direction of the cylinder is in the same direction as the atmospheric pressure. So this process is called a compression process. And then the useful work W is equal to WB, the boundary work, plus the work of the surrounding. WB is the boundary work, which is the movement of the piston, and work surrounding is the pressure by the atmospheric pressure. So we can expand this, and you can see the equation something like this. This is a moving boundary system. So how about the system with no surrounding works? So something like cyclic device, steady flow device, which has only control volume without any volume change. So since it does not have any moving boundaries, so no volume change, so delta V is equal to 0. And work surrounding, since it does not have any boundary movement, so the surrounding works which is from the atmospheric pressure is equal to 0. And here we can say that the useful work is equal to the work done by the system. Reversible work and irreversibility. So what is reversible work? The maximum amount of useful work that can be produced as a system undergoes a process between the specified initial and final states. So reversible, meaning that initial state to the final state, and then the final state to the initial states. The reversible work is equal to the exergy when the final state is equal to the dead state. So the final state is at the dead state. That is the exergy. Irreversibility. Exergy destruction. What is exergy destruction? So it is the difference between reversible work and useful work. So irreversibility I is equal to the exergy destroyed. So the exergy that we cannot be reversible is the irreversibility, and it is the exergy destroyed. So for work producing device, I is equal to reversible work out minus useful work out. For work consuming device, the irreversibility is equal to useful work in minus reversible work in. So the meaning of irreversibility is the waste work potential or loss opportunity to do works. So let's say the irreversibility is equal to 0. So the reversible work will equal to the useful works. So consider a system, steam turbine system. We have a pump, boiler, turbine, and condenser. And looking at the TS diagram of this system, we have 4 state, 1 prime, 2 prime, T prime, 3 prime, and 4 prime, and 1, 2, 3, and 4. So the prime is for the ideal system, whereas in the actual system, we have irreversibility in the pump in state 1 to 2 and in state 3 to 4, irreversibility in the turbine. We also have the pressure drop in the boiler and also pressure drop in the condenser. So here in the process 1 prime to 2 prime, the irreversibility is equal to 0. The same goes from 3 prime to 4 prime. The irreversibility also is equal to 0. This is in ideal case system. However, in the actual system, we have losses. It is the irreversibility in the turbine. So the work useful is less than the reversible works. So this is the work producing devices. So the reversible work should be larger than the useful work. And another one is the useful work is larger than the reversible work. So this is the case for work consuming device, and it should always be like this, where the useful work is larger than the reversible